All right, guys, this is the video for section 7.3, and this is all about proving that quadrilaterals are parallelograms. So before we said if they're parallelograms, they have all these properties. This is more, how do we know for sure it's a parallelogram type of thing. So there's 4 different theorems we have that tells us whether or not a quadrilateral is a parallelogram. Okay, so the first one is the parallelogram opposite sides converse theorem. Okay, so converse. Remember, the converse is when we flip the hypothesis and the conclusion. Now, the parallelogram opposite sides theorem says if we have a parallelogram, then both pairs of opposite sides are congruent. So the converse of that would be if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Okay, so say we don't know that any sides are parallel. All we know is that these 2 sides are congruent and these 2 sides are congruent. Using this theorem, this is enough to say, well, this has to be a parallelogram then. Okay, the parallelogram opposite angles converse, as you could probably tell, this one is if both pairs of opposite angles are congruent, then by this theorem we know the quadrilateral has to be a parallelogram. So let's say that this angle here and this angle here are congruent, and this angle are congruent, but we have no clue if opposite sides are parallel. But it doesn't matter, we don't have to, because by this theorem, just knowing that both pairs of opposite sides are parallelogram are congruent, we can conclude that this is in fact a parallelogram. All right, this theorem is the one that everyone seems to forget, so you might want to like put a star by it or highlight it or just something to draw your attention so you don't forget it. This is the opposite sides parallel and congruent theorem. This is not a converse, okay? This theorem tells us that if one pair, so all we need is one pair of opposite sides are both parallel and congruent, then it has to be a parallelogram. Okay, so for example, if I know that this side and this side are congruent, but I also know they're parallel, that would be enough to conclude this is a parallelogram, okay? Or the same thing about this side and this side, okay? That would be enough to prove it's a parallelogram, okay? What you can't have is one side parallel and the other side congruent. That would not be a thing. It has to be the same pair of parallel sides, have to be both parallel and congruent. All right, the last one would be the parallelogram diagonals converse, and as you can probably guess, if the diagonals bisect each other, then the quadrilateral is a parallelogram. So if I draw these diagonals here, okay, if they bisect each other, this has to be the midpoint of both of the diagonals, and I have to know that this part here is congruent to this part here, and also this part here is congruent to this part here. So I can say this and this are congruent, and this and this are congruent. This would be enough to show this is a parallelogram. All right, so let's go ahead and do some practice problems over those theorems we just did. So I'm going to pause this, and I want you to go through and do A, B, and C on your own. All I need you to do is look at the diagram and then by the diagram, I want you to figure out which theorem you would use to show that these are congruent, or that these are a parallelogram, I'm sorry. All right. Let's go over these. All right, so on A, you're given this diagram, and I've highlighted in green, both of these opposite sides are 30 meters, meaning they are congruent. And then in blue, I've highlighted these little arrows, meaning they are parallel. So I have one pair of opposite sides that are both congruent and parallel, and therefore I would use the opposite side parallel and congruent theorem. On B, I've highlighted in yellow, both of these are 7 inches, so they're parallel. And then in purple, both of these are 5 inches, sorry, they're congruent. And then both of these are 5 inches, which are also congruent. So both pairs of opposite sides are congruent, and therefore I have the parallelogram opposite sides converse theorem that tells me this has to be a parallelogram. And then on C, in blue, I've highlighted opposite angles are 65 degrees, which means they're congruent. And then in green, the other pair of opposite sides are 115, which means they're also congruent. And so if both pairs of opposite angles are congruent, I can use the parallelogram opposite angles converse to show that this is a parallelogram. All right, I want you to go ahead and try example 2 on your own. You should have enough knowledge to do this. So find the values of x and y, and I'm going to add to this. That would make A, B, C, D a parallelogram. Okay, so I want you to go ahead, try this on your own, and then we'll go over it. All right, so in order to make this a parallelogram, you would have to make the opposite angles be congruent. So once again, I've highlighted in the same color the angles that should be congruent. And remember, if they should be congruent, then that means you would set them equal. So if you look down here in blue, I have set 3x minus 32 equal to 2x. Done the algebra, you should have gotten x equals 32. Here on the right in green, I've taken the two highlighted in blue that should be congruent, set them equal, and did a little bit of algebra, and you should have gotten y equals 29. All right, so if we look at example 3, there's several ways that we can do this. We can use the distance formula on all 4 sides to get the lengths and show that both pairs of opposite sides are equal. Or we could use the distance formula on opposite sides and show the length of them are equal, and then find the slope of them, show those are equal, and that's it. But the easiest way to do this, and the way that you're going to make the least amount of mistakes, is just by finding the slopes and then comparing them. Okay, so we can do the slopes just by counting. We don't even have to do algebra to do the slopes. So I want to find the slope of AB, the slope of BC, the slope of CD, and the slope of DA. And if opposite sides have the same slope, remember, same slope means they are parallel. So if I can find that opposite sides are parallel, both pairs of opposite sides are parallel, that would mean this has to be parallel. So we're just going to count, guys. So AB, we're going to go up 1, 2, over 1, 2, 3, 4, 5. So the slope of AB is 2/5. Slope of BC, we're going to go down 1, 2, 3, and to the right, 1, 2, 3. So -3 over 3 is just -1. Okay, CD. Now I'm going to go down 1, 2. So -2 over. And then left 1, 2, 3, 4, 5. So -2 over -5 is just a positive 2/5. And then from D to A, I'm going to go left 1, 2, 3, and down 1, or I guess up 1, 2, 3. So negative 3 over 3 again is a negative 1. So notice negative 1 and negative 1, and then a 2/5 and 2/5. Opposite sides are parallel, or opposite sides have the same slope, so they are parallel. This is all I would need to show that it's a parallelogram.